Okay, I rushed a bit at the end of the last video, so let me say a few more words about ratio and interval level. Okay, so again, they're both obtained through objective measurement, usually through some kind of an instrument. They represent real numbers, not just qualitative or arbitrary numbers. But how do we distinguish the two? First of all, once again, there is not a lot of practical difference between interval and ratio. They both, again, refer to something very objective done. Okay, but one way to distinguish them is to ask, what does the value 0 mean? Okay, so if the value 0 corresponds to the absence of the feature, then most likely you're dealing with a ratio variable. In fact, for now you can assume that you do. Okay. On the other hand, if the value of 0 does not correspond to the absence, then you're probably dealing with interval level. Let me give you some examples. Again, the zero temperature in Celsius does not indicate a total absence of heat. You still require some heat to be at 0 degrees, right? You can go lower than that easily. And so that means that that the temperature in degrees Celsius is an interval variable. On the other hand, if 0 indicates a length, then something of 0 length, it's non-existent, it's not there, and therefore that indicates that you're dealing with a ratio variable. If you have a 0 count, how many times something has happened, and you say 0, well, that means that it didn't happen, right? So there's an absence in there. So we're talking again about a ratio variable. On the other hand, you could have a minimum score on a questionnaire, which still represents absence, but it's not 0. So it's something else. So a score of 20 might indicate absence of whatever it is you're measuring. And so in that case, we're dealing with an interval variable. Alright, so once again, we're going to be doing some more work to clarify the difference among these four levels later. But let's quickly look at some more jargon words that are used in statistics. First of all, a variable is said to be ordered if it is at the ordinal level or higher. So ordinal, interval, or ratio, it's ordered. There is a natural order. And a variable is called numerical if it is interval or ratio. In other words, if its values are true numbers. And as I said, in that situation, the methods are pretty much the same. From a different perspective, we can say that a variable can be continuous if it can take any value between two possible values. So for instance, your height could be 150 or 160 centimeters, or the height of people, and so can be any number in between, right? Even 153.7287. Now, we may not be able to measure it that accurately, but it is theoretically possible. The values of a variable, on the other hand, are discrete if only isolated values are possible. So for instance, if I ask you how many brothers and sisters you have, you can possibly tell me 3.5. So it has to be either 0 or 1 or 2 or 3. Or how many seizures have you had? Well, that can only be 0 or 1 or 2 or 3. You cannot have anything in between. So in this case, we're looking at discrete variables. Now, there is a warning here. There is a strong interplay, as I have already hinted in the very basic examples I tried to give you, between continuous and discrete. Sometimes variables which are continuous are only measured in a discrete way, and variables that are discrete in fact can be treated as continuous. We're going to look at this interplay a little bit better in class and as we apply this idea in other situations. There is another thing that we may want to remember. In high school, remember that there is a concept of independent and dependent variables. So there is in statistics. So we're going to say that a variable is independent if it is one of those that is driving the process. But be careful. We're not necessarily saying that it is the cause of the process, but only that it is in the driver's seat for that process. And the same way, a dependent variable is one which is driven in the process or by the process, if you want. Again, it doesn't necessarily have to be its effect, but it is the one that we are seeing as being the one driven in the process. We're going to see a little bit more about this difference between driving and being driven as opposed to being cause-effect later on. But the one thing to remember right now and for very clearly is that statistical relations do not always indicate causality. So the fact that one variable is pushing or being pushed by the process does not necessarily mean that that variable is the cause or the effect of the process. One little more thing before we're done with this class.